Hi everyone, welcome back to CS128 Honors. I'm Quan Hao, and today we're going to go through our first lecture about programming in Rust, and we'll go through some Rust basics. So we will cover today a kind of crash course for how to start programming in Rust. We'll talk about variables, mutability, the control flow like if-else statements, and how to define functions. And if you prefer like reading the book, you can also look at the Rust book chapter 3, which is where we get the lecture content from as well. And that will help you to understand some of the concepts better. So yeah, let's begin. So the first thing we want to learn in Rust is to how to declare a variable. So here I have an example. So we have let x equals to 5, and then this is very simple. It literally means create a variable x with the value of 5, and then here we have let x colon u32 equals to 10. And what this means is when we have a colon here, we are saying variable x should be of type u32. And usually in Rust, when we create a type like this, if we have equals to 5, you don't actually have to explicitly specify the type. It will default to I32, which is an signed integer of 32 bits. But when you want to use a different types, for example, here I'm using U32, which is an unsigned 32-bit, then you have to explicitly state the type yourself. So this is the kind of overall syntax for declaring a variable in Rust. Next, I will talk about something that I think is special within Rust. So here, as usual, we have the variable let x equals to 5, and then when we print out 5, we'll be fine. Right now, when we write x equals to 6, in a normal programming language, we'll think that this is fine, right? And then x will be 6. But in Rust, what happens is actually there's this concept of mutability. So when we first declare the variable x, it's actually immutable. So this means that once we declare that x equals to 5, we can't actually change the value of x, right? So the way to fix it is actually to add this mute keyword, as we see here. Mute stands for mutable, and it kind of is a way of declaring to the compiler that I want to let this variable be mutable so that it can be modified. Now when we write x equals to 6, the assignment is now valid. So I'll just give a quick demo of how this works. So here I have the code on the left, and then I will do the compilation on the right. Right, so let me just write what we have in the slides earlier. So we do let x equals to 5, and then now if I do x equals to 6, as we said, because x equals to 5, x is immutable, so this statement will be invalid. Right, so let's try it. So again, my editor already warns me that I can't assign twice to immutable, but let's just try to compile it and see the message that it gives. So here I'm going to cargo build, which is to compile the project, right? And we see the main error here, which is that we cannot assign twice to an immutable variable x, which is what we said earlier. And the compiler actually in Rust is very helpful. It tells us the first assignment happens here in line 2, let x equals to 5. And then here we try to reassign again to x equals to 6. And it's because it's an immutable variable, this is illegal. Right, so like we said earlier, the fix is very simple. We just write let mute x equals to 5, and then now we can assign x to 6. Right, so let's try it. Cargo build. Right, we get some warnings about how the variable x is never used, but other than that, the program does compile, and it's a legal program now. So this mutability thing is quite important to Rust, and it's something to keep in mind as you do the homeworks. So we're going to talk about some of the data types in Rust now. There's integers, floating points, booleans, and characters. So integers in Rust are defined like this. They're not written like int, like in other languages, but actually they clearly specify whether you want an signed or unsigned. So unsigned versions will start with u, signed versions will start with I, and then just how many bits. So if you want a 16-bit integer or 64-bit integer or 128-bit integer, right? And the different sizes just specify how large the number it stores can be. And then this arch stands for the architecture. So this I size will depend on the size of your architecture on your machine. So like say you're on a 64-bit machine, then this will be 64 bits, right? If you're on a 32-bit machine, then this will be 32 bits. So that's the one that's dependent on your system. Next, we're going to talk about floating point numbers. Again, it's really straightforward. We declare the variable like this, and if you do not explicitly state the type, Rust defaults to F64, which is a 64-bit float. Also, the more accurate term would be a double precision floating point, whereas here we have Y, where we specify the type is F32, and this is a single precision floating point. Another type we have is booleans. This is the same in every language, I think. In Rust, it's just true or false. It's really straightforward. You don't need the declaration. I put it there just to be clear. And the more interesting case here that we have in Rust is the last type that we should talk about is the character. So characters are defined in single quotes. If you define it in double quotes, it becomes a string literal, which we'll talk more about. But so here is in single quote, and in Rust, the character type is 4 bytes in size. So it's a bit different from the ASCII that we are used to in C, C++, and things like that. So actually, in Rust, you can actually represent special characters like this, like the crab emoji, or like basically a non-ASCII character. So moving on for variables, we're going to talk about conditionals, namely stuff like your if, else if. So in Rust, it's really simple. It's just if, and then the condition, and then else if and else, right? So these two are optional, right? You use it as you see fit. And in Rust, the thing to take note is that when you write the conditionals, you don't actually have to put the brackets, not like you need to do in C. So you just gotta take note of that. Moving on, Rust also has loops, which is like a really primitive programming construct, right? There's 3 types. There's loop, while, and for. Loop is the simplest. It literally just loops. It doesn't stop, it doesn't do anything until you actually tell it to stop with a breaks keyword. While is the same as a while loop in other languages. It keeps running as long as the condition is true. And for will run for a specific number of iterations or through an array. So we'll see that. So the first one we talked about is loop. Yeah, like I said, loop just keeps running until it's told to stop. So here we let x is 0, and we loop, and we write here that if x is 50, it breaks. So obviously this will be an infinite loop that will keep running because we never modify x, so x will never be equal to 50 and it will never break. So loops are useful. They are very primitive, but the thing to take note is that you need to remember to insert the condition to break and make sure that it actually hits the break. While, as I said before, while is similar to other languages. So down here we have while x is not 50, we'll print out x and then we'll add 1, right? So starting from 0, this program will do 0, 1, 2, 3, 4, 5, 6 all the way till 50. Yeah. And lastly, we have a for loop. So actually there are 2 key ways to run the for loops in Rust. The first way is to actually go through each element in the array. So some people will notice that actually this is very similar to Python, where you can just write for number and then inside the an array, and it will actually, so this number will actually take the value of 1, 2, 3, 4, 5, and when we run this, it will print out, I love the number 1 followed by I love the number 2, and so on. And you can use the for loop in Rust to go through any collection and not just arrays. So another way to invoke the for loop, or like the more classic way, is to run it for a certain number of iterations. So in Rust, they use this called range notation. So you run from 0 to n, where n is not included. So in this case, n is 10, right? So you'll run from 0 to 9. And this is similar to C and C++, where you have for int I equals to 0 and then int smaller than n. Lastly, we're going to talk about functions in Rust. So this is a function signature in Rust. So you use the fn keyword, and then this is the function name plus 1 here, and then these are the parameters or the arguments, right? So for example, in this function, we take 2 parameters, x and y, and similar to your syntax for declaring variables, you will do the name of the variable, colon followed by the type. Right, so unlike when you declare a variable, the type here for functions is actually mandatory. You have to specify the type, and then this is the return type. So here we have a very simple program, which is if y is true, then we return x plus 1. If not, we return x plus 2, right? A very interesting thing about functions in Rust is that you don't actually have to explicitly use the return keyword. So in programming, in a source code, there are 2 types of kind of syntax, right? The first is statements. Statements are complete instructions. Like they do the instructions, but they don't return anything, right? So for example, we let x equals to 5. This is a statement, right? We are just declaring that we have a variable x and it's 5. But this doesn't evaluate to any value, or it doesn't return anything, right? On the other hand, we have expressions. So for example, x plus 1 is an expression. It evaluates to some value, right? So we can have x plus 1, or we can have just x is also an expression, right? So in Rust, you can actually leave the expression as the last line of a function, and the compiler will actually treat that as the return value. So it implicitly returns the value of the last expression. So in Rust, it's very common to write a function. Say, okay, let me go to the demo. So let me write let me write a function here. So let's write a test function that takes in an x that is an i32, and then it returns an i32 as well, right? So say we do something with x. So we have let y is equals to x plus 5, right? So usually if you want to return y, you write return y like this. But in Rust, you can actually just do this. So y is an expression, and it will basically just return the expression that's in the last line, right? So say in main, if we call let a is equals to test, let's say just 5, right? And so we pass 5 into the function, we'll get x plus 5 is 10, and it will return 10, right? So we expect the value of a to be 10. So let's try it. And let's try to run it. So here on the left, I'm going to run cargo build, not on the right, I mean. And it will build, okay, and then let's try to run it. And it will show us 10, as we expect. So here in Rust, I think the special thing is just to note that the return expression in the last line of a function, you don't actually have to write return. Yeah, so that's functions, and I think that's all we have to cover the Rust basics about declaring variables, mutability, and functions. Just some announcements. So together with this lecture, homework 1 is also released on Prairie Learn. It's due next Friday, and that's for full credit, and for 1 week after that there will be 70% credit if you still complete the homework, right? And we're still before the class adding deadline, so remember to do the onboarding task and register for the class if you have not. You can check the onboarding form. You can find the onboarding form either on Discord, in the syllabus, or in the CS128 forum as well. So have fun coding Rust.